Hello friends and welcome at my channel. Today I would like to still do some more limits with trigonometrical functions. I hope you enjoyed the previous videos, so let's do 3 more today as well. We start with limit x towards 0 from the positive side for 1 minus cosine of x divided over x. Do we have to call it positive side? Well, no, right? Doesn't matter because we're approaching 1. We cannot be more than 1. If the cosine could be more than 1, then maybe we should make distinguishment. Otherwise, no problem. So forget about that. And how can we approach it? Well, we have the case where we have 0 divided by 0. Normally, maybe we learn it with L'Hopital's rule. You produce derivatives and everything is fine. We'll get there once, but we're not there yet, so I just want to solve it with only given formulas from trigonometry, like this is 8th or 9th year at school, but no further, more advanced techniques are needed. All right, so what we're doing here is we remember the formula of doubled cosine of 2 times x divided by 2 right here. So 1 can be written as sine squared of x divided by 2 plus cosine squared of x divided by 2 minus, and now we're just writing cosine squared of x divided by 2 minus sine squared of x divided by 2. Now you see what's happening. If we solve the parentheses, this is minus, this is plus, those two are gone, and plus plus, we're going to get 2 sine squared of x divided by 2. So we are getting to limit x towards 0, 2 sine squared of x divided by 2 divided just by x. And we're taking the square root out of this. Now you see why I was doing this, because we are now having limit x towards 0. We get square root of 2 separately. Square root of the sine squared is just sine itself, all right? So we just have sine of x divided by 2 divided over x. And as you learned maybe in the previous videos, we would like to have the same arguments, so we're dividing by 2 and multiplying times 2 at the same time, not changing anything. Now we can kick square root of 2 divided by 2 outside of the parentheses, outside of the limit. So we're going to get square root of 2 divided by 2 times limit x towards 0. And now we have sine of x divided by 2 over x divided by 2. This one is familiar. Limit, it's 1, and square root of 2 divided by 2. It's a pretty nice value. Simplified, of course, a little bit. And this is at the same time cosine or sine of pi divided by 4 or 45 degrees. Right? You remember that? Okay, so number 1 is solved. Let's move on. Number 2. There you go. Number 2, we got limit x towards 0 sine cubed of x divided over sine of x minus tangent of x. Okay, the very first step, we start with limit x towards 0 sine cubed of x divided over sine of x minus sine of x divided over cosine of x. So in the next step, we are just taking sine of x out of the parentheses. We're getting 1 minus 1 divided by the cosine of x, right? So we're canceling it. It remains still squared. We're having limit x towards 0 sine squared in the numerator. In the denominator, we're getting cosine of x minus 1. We'll bring it to the same denominator. And we're dividing by the cosine of x, which means we're multiplying times the reciprocal, so the cosine flips to the numerator. We're getting x towards 0 I'm just rewriting sine squared as 1 minus cosine squared of x times cosine of x, still divided over cosine of x minus 1, right? Okay, so do we have troubles still? Yeah, we have troubles, because if we have x equals to 0, the denominator going to be 0, the numerator as well. But as you can see, maybe we have a binomial formula here. So we have a limit x towards 0. Let's take a minus just from the denominator, so I can rewrite it as minus here. And so I just flip the order. And so I'm going to get, so minus is still here, 1 minus cosine of x. And now you see why I was doing this, because now we have 1 minus cosine squared here, which can be written as 1 minus cosine of x times 1 plus cosine of x times, we still had cosine of x remaining. And now the problem with the denominator is solved, because we can cancel it. And now we have minus limit x towards 0, 1 plus cosine of x times cosine of x. So if x is 0, cosine of x is becoming to 1. We got 2 times 1, which is 2, and minus in front, we got minus 2. Okay, question 2, check. Let's move on to question 3. And the third interesting example is just to have limit x towards 0. We're having 1 plus sine of x to the power of 1 divided by x, right? So one more variation, which is, well, just nice, I think. What we're doing, we're multiplying it times sine of x divided over sine of x in the exponent here. So what is happening is we have a limit x towards 0, having 1 plus sine of x to the power of 1 divided by sine of x. And now we use the power rules, to the power of sine of x divided by x. It's so nice because this limit is known as 1. And what is happening here? Well, we have to understand what's going on if the x value is approaching 0. Well, let's call it from the positive side. Doesn't matter actually, because this is the same function, but let's say for the sake of argument, it's just positive. So you see, if we call sine of x 1 divided by sine of x to be n, then sine of x is just 1 divided by n, and you see if x is approaching 0 from the right hand side, n is going to be infinitely positive, large, positive. So we're switching to limit. We're doing now two limits. First of all, we're having x towards 0 to become n towards infinity. We have 1 plus 1 divided by n to the power of n times the limit x towards 0 from the positive side. Here I don't want to change anything. Sine of x divided by x. This one is 1, and this one is the Euler's number. So we got e to the power of 1 over just e. Isn't that nice? I think it is. Thanks for watching. See you guys in the next video. I'm not getting enough of this limit, so I think I'll keep on doing it for a few more videos. I hope you'll enjoy it as well. Bye-bye.